So the problem says a stone is thrown at 20 meter per second at an elevation of 40 degree from the top of a 60-meter cliff. So let's say this one is the 60-meter cliff. From here, this is ground. From here, the stone is thrown at 40-degree angle. It should go like this. At some point, it should come to the level of the throwing point, and then it will come down the ground. So it says how long it takes to reach the bottom. That means how long it takes to reach here. Find its distance from the foot of the cliff. So this distance we need to find, and at what angle. So at what angle it enters the ground basically, or enters the sea. So yeah, since there is a cliff, so we need to find how long it takes to reach here. So we can divide the flight path into two sections. One is this one, and we know when it reaches maximum height, the vertical component of the velocity will be 0. So at this point the velocity will be 0. Using that, we can find the time it takes to reach here, up to here, and we will twice it to find the time that it takes to reach here, up to this point. So if we say this one is point B and this one is point C, in order to reach at point B, the time, if we say the time is t, it will take 2 times the time it takes to reach the maximum height basically. So this one, at this the vertical velocity is 0. So if we use this equation, u minus gt, this will be 0. So this will be, these are all vertical components, so bv, so that will be 20 sine 40 degree minus gt, so t will be 20 sine 40 degree over g, and our this t will be the 2 times, so 2 times 20 sine 40 degree over g basically. So that is 2.62 seconds. So that's the time it takes to reach at point B. Now from point B to point C, how long it takes, if we want to find that, we have to figure out the height, which is 60 meter. So we can use this equation, h is equal to ut plus half gt square. If we remember that, of course here again u will be the vertical velocity, and that will be the velocity at this point here. So that velocity is the same velocity that was here, only in this at this point it is downwards, and that's why we have used plus equation, because it is accelerating downwards. So our equation becomes 60 here, height, and this will be 20 sine 40 degree t plus half 9.8 t square. So that is 60 12.85 t plus 4.9 t square. So this is a quadratic equation. If we want to solve it, we can write it like this: 4.9 t square plus 12.85 t minus 60 is equal to 0. So t will be 2a, which is 2 times 4.9, minus b will be minus 12.85, plus minus b square, which is 12.85 square, minus 4ac. So it will be minus 4 minus 60 times 4.9. So we will have two roots, and once we calculate it, we will see one of the roots is negative, so we will discard it since it's time. The other one is positive, and I'm just writing it directly. It is 2.43 seconds. So that's the time it takes to reach at C from which is at C, the ground level, from B. That's the time it takes. So our total time will be how long it takes to reach from here to here, from A to C, will be this one, which is 2.62 plus 2.43. So total time is 2.62 plus 2.43, which is 5.05 seconds. So that we know now. The second part is how find its distance from the foot uh, of the cliff basically. So from here to here, what is the distance? So we know that in order to find this distance, all we need is the horizontal component of the velocity times the total time. And the horizontal component of velocity does not change throughout the flight. It stays the same. So that is always the total distance, if we say r range, that will be u cos alpha, which is 20 cos 40 degree, the initial angle, times 5.05. So that is 77.4 meters. So that's the distance from the foot of the cliff, that is this distance basically. Finally, we have to find at what angle does it enter the sea. So in order to do that, we have to find what is the velocity at this point at C. And again, when we say velocity, we are talking about the vertical component of the velocity, because horizontal component of the velocity is still the same. So if we think of this equation, v is equal to u plus gt, plus because it's this accelerating downwards, and we are talking about from point B, so u is equal to at point B, and this one is at point C. So this is again, these will be all vertical velocity. So this is again 20 sine 40 degree, because that's the velocity, downwards vertical velocity, plus 9.8 times the amount of time it takes to, that is this one, from B to C, 2.43. So that is 37.64. This is the vertical component of the velocity at point C. So 37.64 is the vertical component of the velocity, and the horizontal component of the velocity is of course again the same as before, 20 cos 40 degree, and the division will be, so the vertical one divided by the horizontal one is the angle basically, a tangent of the angle, if we say the angle to be theta. So if we find theta inverse, tan inverse of this one, which is 37.64 over 15.32, we get the angle, which is 67.8 degree. So that is the angle at which it is entering the sea. So that's the problem here, that's the solution here basically.